Radicals are numbers that are non-perfect powers inside roots, and these all end up being irrational numbers or numbers that cannot be put into fractions. So if we take a look at square root of 5, this is a radical expression because 5 is not a perfect square, so it cannot be expressed as a whole number or fraction. When we take a look at square root of 16, or sorry, the fifth root of 16, 16, although it's a perfect square, the index here is 5, so we need to look at the inside number. And since it's not a perfect power of 5, this can't be undone, and we can't get a whole number out of this, so this is considered a radical expression. So cube root of 53 is a radical expression because of the same reason. Now, where these were first discovered was when they were trying to find the length of the diagonal of a square of side length 1. And when they tried working out this length by using Pythagoras, okay, we did 1 squared plus 1 squared is equal to the c squared, and we get 2 is equal to c squared. And when we tried to take the side length of a square of area 2, we ended up with a number that cannot be put into a fraction. Now, this was a bit puzzling at first, and eventually people realized that this is just a different type of number, or an irrational number. Now, these radicals show up in two different ways. They show up as mixed radicals, where they have a whole number part and then a radical part, or they show up as whole radicals, when they have the whole radical, or whole number inside the radical. Now, these have different uses. Whole radicals are useful for comparing different sized squares. So square root is finding side length. So when we want the side length of a square of 72, we can compare that to a square of the side length of a square of size 50 squares. Okay, so when we square root these, it's easy to compare these two because we start with a bigger square here, smaller square here. So the side length of the bigger square must be bigger than the side length of the smaller square of 50. So they have different uses. The mixed radical is useful because we can actually do way more algebraic manipulations with them. So we are in the end going to want most things in a mixed radical form. And when we do that, we can combine like radicals, and we'll be doing that later, but we can group radicals together in their mixed radical form much easier than we can when in their whole radical form. So the first thing then we're going to do is we're going to convert radicals from their whole radical form to their mixed radical form. So for example, a square root of 72, we can convert to a mixed radical. So this is a whole radical. We can convert that to a mixed radical by taking out the perfect square parts of that, or the perfect square factors. So when we look at 72, we can factor it into a perfect square of 36 and a non-perfect square of 2. Well, that perfect square of 36 can be separated out as square root 36, which we can work out as 6. That works out to be the whole number part of the square root. So we want that on the outside, and then we're left with the non-perfect square part of 2, and that gives us the radical part of that mixed radical. So converting a whole radical to a mixed radical, we're taking out the perfect square parts. So another way we can look at it is the perfect squares come outside the radical, okay, and they end up outside the radical as whole number parts.